So in terms of atoms, I want to try to keep this as simple as possible. So when we talk about atoms, we're basically talking more specifically about what makes up stuff. Yesterday we talked about matter in like general terms, and we talked about solid, liquid, gas, states of matter. But when we talk about atoms, we're talking about what that matter is actually made up of, right? And so if we take anything, right? It could be this calculator, it could be the book, right? It's made up of, an unimaginable amount of little atoms. And so atoms are a term that we use to describe matter that cannot be broken down any smaller, right? So atoms are the smallest possible type of matter that we have, right? And so the basic atomic structure, and actually, hold on a second, I'm going to actually share something different. And then I'll come back. Give me just 1 second. I'm going to share. Okay, so hopefully everyone can see this. This is kind of the very generic diagram of what an atom looks like. And it's not perfect, and it's overly simplistic. This will give you the idea. So an atom, or a particle broken down of matter, is made up of all these different components. So an atom has a nucleus. So the middle of the atom is the nucleus. And the nucleus is about 99.99% of the total mass of the atom. So we talked about mass a little bit yesterday, but mass is basically I don't want to use the word weight. Weight factors in gravity, but essentially how big something, right, and how dense it is. So the nucleus is makes the entire atom, and the nucleus is made up of these red protons and the green neutrons. And they're just red and green just to show you that they're not actually what they look like. And then orbiting around the outside of these nuclei are what we call electrons. And so to keep things kind of short and sweet, those are really the only parts of the atom that you need to remember, right? Nucleus, which consists of the protons and the neutrons, and then the electrons, which are around the outside. Okay, so kind of keep this diagram in mind as we go through stuff. But I'm going to go back to my PowerPoint. So again, try to keep that visual aid in mind. And thanks for letting us know on that. So, all right. Sorry, I'm putzing around here. I promise I'll get back to this in a second. Just loading it up too much stuff up. Come on. There we go. All right. So, sorry for that. Back to where I was trying to get. So, the atom, again, is made up of the nucleus, which has two different types of particles, protons and the neutrons. So, the way that these atoms work, and the way that they're kind of held together, is through these electrical charges. So protons actually have a positive charge, and neutrons have no charge. They're neutral. They're not negative, they're neutral. So protons have a positive charge and neutrons have no charge. So the nucleus of an atom is positively charged, right? Because there's only protons in there, and then there's neutrons, which add nothing to the electron. And then orbiting around the outside, we have negatively charged electrons. So that's what keeps them together, right? And so that positive negative. Think of like a magnet. This is kind of a dumb example, but think of a magnet, right? If you have two magnets, if you put the like ends together, they repel away from each other, right? But if you flip one of the magnets around, right, and you have kind of the negative charged end up against the other magnet's positive charged end, they attract to each other, right, and they connect. Like my 3-year-old's toy trains, the little wooden trains, that have the magnets. If I put them together one way, they repel. If I turn them around the other way, they attract, right? That's essentially how atoms are held in place. That positive and negative balance. Okay, so again, don't want to get hung up on all of this stuff because again, with science, you don't have to be an expert with chemistry or physics or biology to do well. So that's as much talk about atoms as I want to get into. So periodic table, and I'm kind of debating on whether to go over the periodic table today or tomorrow or whatever, but probably heard of the periodic table, you've probably seen one. But essentially, the periodic table is organized in rows and columns, and those are basically all of the different elements that exist in our known universe, right? Elements that we've discovered, right? There's more out there, I'm sure, but in terms of elements we've discovered, they're all kind of listed there on the periodic table. So actually, since I'm talking about it, let me just pull. A real quick picture of one. Let me. All right, so nothing fancy, and hopefully you can see this zoomed in. Oh, God dang it. Come on. Okay. So hopefully you can see this. If not, alert me in the chat. I can see the chat now. But the periodic table is just the list of all the different elements. And again, this isn't stuff that you need to memorize, right? And we probably won't get into specifics of kind of how things are organized. And yeah, these always will be posted as soon as we can get them up on YouTube. We'll post these afterwards. So here is the periodic table of elements. All these different symbols just stand for the different elements, right? So we will spend a different day talking about that, but I want to actually just kind of go through some practice questions. And since these science questions are a little bit more complicated, I want to spend some more time on the questions today than I normally do. So let me here. Sorry, my internet seems to be kind of acting slow today. All right, so let's look at this first question. So sodium is represented by the symbol Na. So the element sodium, although it was on that periodic table, and it had the symbol Na. And chlorine is represented by the chemical symbol Cl. So this says, this might, damn it. I see that we need another page of this, so I may not do this. Man, sorry, bear with me, Serenity. We'll get through it. I want to actually just go over this. little bit distracted today. I've got my lovely children distracting me. But anyway, let's skip number one and just go through this one because we don't have to have any other materials in front of us to do this. So it says water is composed of 2 atoms of hydrogen and 1 atom of oxygen, as the formula H2. Well, let's just stop there for a second. Just to kind of reiterate, when we talk about, let's take water for example, right? We've all heard of H2O, and that literally means water has 2 hydrogen atoms and 1 oxygen atom, right? And together they make 1 molecule of water. And so they go on to say that glucose, simple sugar, okay, consists of 6 atoms of carbon and 12 atoms of hydrogen and 6 atoms of oxygen. Okay? Which of the following is the chemical formula for glucose? So look through those, and whichever students are in class, go ahead and type your answer in the chat, and then we'll go through your answers. So I'll give you a minute to do it, and then we'll go through it. So if you're totally at a loss and you're not sure, take a look at the water, right? That's the hint. That the 2 here stands for what? That there are 2 hydrogen atoms. And you would guess D, and you would be correct. Nice. D is right, right? So here's an example of a question that might sound confusing. There's lots of terms and words you might not understand, but just by looking at the example and the H2O and how it's written there and applying that same logic to a new unknown chemical formula, we can tell that D is right because the 6 here refers to 6 carbons, 12 here refers to the 12 hydrogens, and the 6 here refers to the 6 oxygens. Great. So let's go ahead and look at next question here. So let me zoom back out a little bit. So here is kind of a less straightforward question. So let me see here. I got it. Can you read number 4, okay? Hopefully you can read it all right. But go ahead and try this. So this is an example of, something. Yeah, go ahead and do number 4. Yep. So read through the paragraph, and I'll read it as well out loud. But then you can go ahead and answer the question when you get a chance. This is an example of something you might see in the test where there's a pretty good chunk of reading that goes along with. So in 1911, British scientist Ernest Rutherford performed experiments that increased our knowledge of atomic structure. He bombarded an extremely thin sheet of gold foil with helium nuclei. The dense nucleus is the middle of the atom, the main part of it. Helium nuclei, which are called alpha particles, 2 protons and 1 neutron. So very, very small. He found that most of the helium nuclei passed right through the foil. Only a few were deflected back toward the source. On the basis of this experiment, Rutherford concluded that an atom has a dense nucleus with electrons orbiting around it, but consists mostly of empty space. So this is essentially how we came to figure out what an atom might look like. Right, so remember that diagram, the dense nucleus and the electrons orbiting around the outside. So which of the following is evidence that atoms consist mostly of empty space? A, helium nuclei consist of 2 protons and 2 neutrons. B, most of the alpha particles passed right through the gold foil. C, a few alpha particles were deflected off the gold foil and bounced back toward the source. Or D, electrons orbit a dense nucleus consisting of protons and neutrons. Okay, so your guess over there. Let's talk about this one, because this is a good question to kind of spend some time breaking it down. So helium, let's look at A. Helium nuclei consist of 2 protons and 2 neutrons. Now, is that true? I can go back here and look, and indeed in the paragraph it says, helium nuclei, also called alpha particles, consist of 2 protons and 2 neutrons. So it's a true statement. So A is true, but it doesn't necessarily answer the question they're asking. They're asking us, which of the following is evidence that atoms consist mostly of empty space? So A doesn't answer that question. Okay, so A, even though it's an accurate statement, isn't the right answer that we're looking for. So that's something the GED loves to do, is give you options that seem right because they're true. They're accurate pieces of information from the text, but they're not answering the question they're asking. Let's look at B and C because they're similar to each other. B says most of the alpha particles passed right through the gold foil. And C, a few alpha particles were deflected off the gold foil and bounced back toward the source. They're kind of saying the same things, but one is worded as most of the particles passed through, and the other is worded some of the particles bounced back, right? They're kind of saying the same thing. So let's come back to B and C. And let's look at D. Oh, now you're changing your mind, I see. Now you think C. Okay, so D, and I'm not sure why the switch, but you're on the right track, is because D, just like A, is a true statement. So D, electrons orbit a dense nucleus consisting of protons and neutrons. Just like A, that's true. That is what atoms, how atoms are structured, but it doesn't really answer the question as to why atoms consist mostly of empty space. Or not why, but what is evidence of that, right? Because this guy performed this test, and B or C, one of them is right. So you're right on that. But the correct answer is actually B, not C, because of the way it's worded. It says most of the particles passed through, which implies that most of the atom is made up of empty space. Does that make sense, kind of? So even though B and C are very similar, just the way that it's worded makes B the better choice, according to the GED, right? So you could make a case for saying C is accurate, but unfortunately you're going to lose that case because it's a multiple choice test and we don't get to decide which answers we like, right? So for that one, that was kind of more than I needed to explain, but hopefully that kind of makes sense. All right, so let's look at this last one. Let's just do number 5. Number 5 is a little bit easier. So go ahead and read through number 5, and I'll give you a second. So number 5 here says, and if you're not done, that's fine. Just kind of keep going through it while I'm talking. And for other people that are watching this or will watch it later, I'll just kind of talk through it. So number 5 says the number of protons in the nucleus of an atom is called the atomic number. Each number has a unique number of protons in its nucleus, therefore a unique atomic number. So just as a side note, when we're back on the periodic table, and if I can get a little more organized, tomorrow we will look at the periodic table and try to break down what's on the table a little bit better and in more detail than I wanted to show it to you briefly today. But the numbers up on the top, each element they're numbered 1 through whatever, right? And those numbers that they're ordered by are this atomic number. That's what we're talking about, right? And so each element has a unique number of protons in its nucleus, and therefore a unique atomic number. So the question asks us, the atomic number of the element sodium is 11. How many electrons does a non-ionic sodium atom have? And then this is kind of an unfair question because we didn't really talk about ionic or what that means. But the answer here, and the key here is, and I was really setting everyone up for failure here because I probably haven't properly explained everything beyond this. But in a normal atom of any particle, any material, right? So whether it's sodium or whether it's helium or whether it's gold, right? A normal atom of that element has equal parts, protons and electrons, because the positive and the negative charges have to be equal, right? And so that's the non-ionic thing comes into play when we talk about bonds, and we might get there tomorrow, or we might not. We might get there the fall. But that changes the number of electrons in an atom. But in a regular element, or in a regular atom of any element, the positive and negatives are equal. So this is as simple as if sodium has 11 protons, then it has 11 electrons. And that's it. The answer is just okay. So again, I apologize. I set you up for failure on that one. So let me stop there.